This this time we are going to call this triangle similarity. Okay, well, let me type it for you. So this will be our last lesson for our third reading. Okay, triangle similarity. Now, for us to tell that the triangles are similar, so say for example, I have a triangle here and another, okay, and another triangle here. Say for example, this one. Now, say this is our triangle 1, or I guess let's use variables here. So say this is triangle A, while here this is triangle B. Okay? Now, for example, this side measures 5. Okay, let me use another color. So this side measures, say this is 6. Here this is 2. And this one is, say for example, this is 4. And say this is, let me change this one so that you can see the difference. Say this is 3. And here this is 2. Say this is 4. While this angle here is congruent to the angle of this triangle B. Now, we're going to check if the proportion this time 6 is to 3, which is it proportion to 4 is to 2. Now remember, 3 and 4 is our mean, right? This is our mean. While, okay, while 6 and 2, this is our extreme. So let me type it for you. This is extreme. Means and extremes. Okay. Now for us to check if they are proportion, means and extremes must be equal. Okay. So means must be equal to our extremes. So that these two terms or ratios must be proportion. So we'll multiply them. So this is 3 times 4, this is 12, right? While 6 times 2, this is also 12. So as you can see, our means is equal to 12, and our extremes is also equal to 12. Therefore, these two triangles, okay, triangle here, this is triangle A, let me type it for you. Triangle A and B, they are, okay, they are similar, right? Okay. So triangle A and B, they are similar. Why? Because of side, and this is also another side, and this is their angles, the included angle. So that is side, angle, side, similarity, theorem. So this is how our side, angle, side, similarity theorem stated. Okay. So what about the other, for example, other theorem? Say here, let me show you another triangle. Okay, one. Here, triangle. Okay. Another triangle. Let me show you another triangle. Oh, smaller one. Now, what about if this angle here, say this is triangle, this is triangle C, and this is triangle D. Now, say for example, okay, let me use my pen. This is triangle C, while here this is triangle D. Okay, so say for example, the angle here of angle C, triangle C and triangle D, they are congruent, while the other angles of these two triangles, like say this one, they are also congruent. Does it mean that these two triangles, triangle C is similar to triangle D? In fairness, this is true. Why? Because of our angle similarity theorem. Okay. Now, no need for us to prove that the third angles are congruent, because the sum of the measure of the interior angles of a triangle is always equal to 180. So, for example, this side here, okay, this side here measures 30. So, meaning, beside this angle measures 30, therefore this is also 30, right? While if this angle measures, for example, 80, okay, this is 80. Therefore, this angle measures 80 as well. So what is the measure of this third angle? So 30 plus 80 is 110. So for us to complete 180, so this must be 70. Okay, since this is 70, don't tell me this angle here have different measure. So for sure this is also 70. Because 30 plus 70 plus 80, 30 plus 70, that is 100. 100 plus 80, that is 180. So that is how angle similarity theorem stated. Now what about the last one? Say here, we have triangle. Say this is triangle and another triangle here. Say this is triangle. Okay. This is triangle, shall we say E. Okay, let's have a look at the letter E and F. Now, say the side here measures 3, 5, and say this is 7. Okay, and the triangle F, say this is 6, this is 10, and this is 14. Okay, so we're going to get the proportion, the relationship of each friendship. So if we're going to have here 3 is to 6, is it proportion to 5 is to 10? What about 5 is to 10? Is it proportion to 7 is to 14? Or what about 3? Sorry. Again. I need more space. There you go. Okay, let's, oh, sorry, zoom in. Ouch, sorry. Let's zoom. Okay, here, this one. Well, let's enlarge this for a while. Let's zoom in and let's adjust. So say for example, again, say here is the ratio 3 is to 6 proportion to 5 is to 10. What about 7 is to 14? Is it proportion to 5 is to 10? And lastly, 5 is to 10, is it proportion to 3 is to, no sorry, 7 is to 14? Well, let's find out. The means here, okay, how much is this? This is 30, right? So this is 30. What about the extreme? So this is also 30. Therefore, they are proportion. So we've got the first side. What about here? How long is this? 15 times 14 times 4. So this is 70, right? Well, how about this one? Is this 70 also? Yes, for sure. This is 70. So the next side, they are also proportion. What about this one? I guess they are just the same. We'll erase this one. So what is the third side? Okay. We'll erase this. Okay. So they are just the same. What's our missing side here? We'll have 3. Okay. 3 is to 6. Is it proportion to, there you go, 7 is to 14. So let's find out. So say here the means, okay, the means are 6 and 7. How much is 6 and 7? This is 42, right? How about 14 times 3? Is this also 42? Yes, for sure. So this is also 42. Therefore, we've got the third side, which is also proportion. Therefore, how come triangles E and F are similar? So triangle E and F, triangle E is similar to, of course, I cannot write here. Let's have the bottom part. Okay, the triangle E is similar to triangle F. For what reason? As we have shown, there are 3 sides, okay? There are 3 sides that are proportion. So we can say that these 2 triangles are similar because of the Side, side, side. Similarity theorem. Okay. So here, let me write for you the symbol for similarity. So I guess that's the theorems that you're going to remember in terms of triangle similarity. Now on my next video, I will show you some problems on how to solve applying this triangle similarity. Well, please see the next video. Good luck and God bless. Bye.